So for so far, the quizzes and tests that we've had on Delta Math or on Blackboard have been 5. I am posting one more. You have to have done 5 out of 6 to get full credit. Now, this is your response. I will send you an email. This is what I'm going to do, certainly by the weekend. I know that I promised Jonathan that I would give you a score as to what your averages at this point, excluding the final. And I will still do that, but I'm going to do that like the beginning of next week. What I will try to do before or certainly over the weekend is to tell you if you are missing any tests or any homeworks. In other words, I'm going to go to each person. I'm going to count up how many homeworks they've done. If you've done 17, I will say you've got complete credit for your homeworks. If you've done, and then I'll look at your quizzes and tests. And if you will have done 5 out of the 6, I will tell you that you have completed all your quizzes and tests. I'm not going to give you, so first I'm just going to tell you, are you missing any work? If I see that you've only done, let's say 12 homeworks, I'm going to write, you are missing 5 homeworks and you are missing 1 test or quiz. Again, there's going to be 1 more test or quiz, whatever you want to call it, posted on Blackboard. It's going to be posted today after class. It's going to be on conics and trigonometry. That is going to be the 6th test that we will have, class test quiz that we'll have this term. You, to get full credit for the tests and quizzes, have to do 5 out of 6. Now, let me tell you, if you've done all 6, then I'll just count the marks on the 5 best. So I'm only going to count 5 marks. If you've done 5, that's going to be your mark. If you've done 6, I will make sure to count the 5 best out of the 6. Does anybody have a question as to what I'm talking about? So
I do, Professor. I am so sorry to interrupt you. Okay, so I don't know if I was a little probably sleepy or something, but that quiz the test, the practice final that we have on Blackboard, right?
Right.
We're gonna take the practice final and then we're gonna take the regular final. Did you say that whichever mark we get better, that's the one that you're gonna use?
Okay. I said that on the practice, if you do the practice final, and you do better on that than on one of the other tests or quizzes that we had, I'll use that mark. No, I use it in
the final.
Okay. The only thing I cannot look away from, what I must keep as your score is the midterm and the actual final, not the practice final, because that comes from the department and they're going to see the mark and they're going to say, well, how do you, their mark, I see on your mark that you got an 80 and you gave this girl 90. How come? I know I have to, so, but I did say, and I'm glad you reminded me, is that if you do the practice, I'm not counting the practice final as a test, but if you do it, and it makes sense that you should do it, and you do well, actually you're getting 2, I set it up so you could have 2 chances. When it comes to the final, you're not going to have 2 chances, but on the practice final, I'm giving you 2 chances, and if you do well on that, and you did score better on that than you do on, let's say, one of the quizzes, or you're missing a quiz, or so really, when you think about it, there really are going to have been a total of 7, and you only have to do 5 out of the 7. I will count the best marks. If that practice final, you get a 95, and on one of the quizzes you got a 70, I'm going to change the mark on the quiz to 95. Does that make sense to you, Jennifer?
Yeah, it does. Thank you.
Okay, no, but it's not in place of the final exam. Um, I know I'm taking time. So there's a class, right? There's going to be one more quiz posted, and I'm going to actually give you until next Friday to do it. I've already set it up. I just want to make sure I'll right after class I'll check the dates and everything and make sure that it's open for you. But you have it's only 10, it's 10 multiple choice questions. It's a good review for you also because it's a review on conic sections. That's what it's on, conic sections and trigonometry. Um, so look out for a email from me telling you if you have all your work completed as of now, or you still have to do something. It is really your responsibility to look on your Delta Math account and also on your Blackboard account and see if anything is missing. Again, there will have been two quizzes, two, two class tests on Blackboard, a practice final, and a midterm and a final. So there are going to be a few tests there on Blackboard, and then there are four quizzes on Delta Math. So I've been testing you a lot and giving you a lot of homework, but I'm going to allow you to have, for complete credit on your homework and participation, you have to do 17 out of the 21, 22 homeworks that are posted on Delta Math, and you have to do out of the total of 6 quizzes, the sixth one being posted today on Blackboard, you have to do 5 of them. And again, if one of those marks is not good, but you did the practice final and it is good, I'll exchange that mark. So I'm trying to give you the greatest, the highest mark you possibly can get and deserve. Obviously, I'm going to take it into consideration if you didn't finish your work. The big thing is very hard for me to see how you're doing a test. But if you've done the tests and you've done the homeworks, then I know you've been participating and being part of this class. And I think you've learned. And that's what the point of this class is, that you should learn so that you can go on to the next course with sufficient knowledge to do well in that course as well. All right, so let's look at these 2 problems that I gave you. I'll repeat this towards the end of the class again. So I'm going to have to erase it now because I just need the board space. But don't forget your final exam, which is worth 35% of your grade. It's a large percent of your grade is that final exam. It's not 100% of your grade, but it's 35% of your grade. It's going to be 2 weeks from today, May 20th, from 10 until 12. If you have a problem with the timing that you can't do it at that time, you must be in touch with me as soon as possible so I can set up a time that'll work for you. Okay, let's look at this problem first. We were talking about working with exponents on Tuesday, and I'm just going to remind you what these type of exponents mean. Now, first of all, what we remember is that if there was a parentheses, that the first thing we're going to try and do is remove our parentheses by distributing the exponent on the outside to all the exponents, to all the letters in the inside. Now, since this whole fraction is to the -3 exponent, we're going to have to do each one of these letters to that -3. And that's going to be my first step. And I remember when I have a base with an exponent, raised to a second exponent, like this is x to the negative 5 to the negative 3, what I do is I multiply those two exponents together. So the negative 5 times the negative 3 is going to give me x to the 15. Y to the negative 2 to the negative 3, 2 times negative 3 is y to the negative 6. Doing the same thing, remember this is all in that same parentheses, so it's x to the negative 3 to the negative 3 is going to give me x to the positive 9. And y fourth to the negative 3 is going to give me y to the negative 12. So the first thing in the simplification process is to distribute any exponent that's outside of parentheses to everything inside the parentheses. The second thing to do is make your, I'm gonna, let me do this. Make your division line, your fraction line, and look at each of the individual letters and decide whether you should leave it where it is in the position that it's in, or whether you should move it. Remembering that when you have a negative exponent, that's telling you to take the reciprocal, which means that if it's on top, you move it to the bottom, or if it's on the bottom, you move it to the top. If your exponent is positive, you don't have to take its reciprocal, so you just leave it where it is. Good morning, Melissa. So the x to the 15th, we're going to leave on top because its exponent is positive. I'm going to go through each thing separately. The y to the negative 6 has a negative exponent, so I'm going to take its reciprocal, so that means put it in the denominator and make its exponent positive 6. That takes care of everything on top. Then I go to these x to the 9. Now the x to the 9 has a positive exponent, which means I leave it where it is. And I can put it up first, doesn't matter. I do not move it because its exponent is positive. But the y to the negative 12, I do have to move. So that is, since it's in the denominator, gets moved to the numerator. So at this point, I should have only positive exponents, which I do. I have an x to the 15th, a y to the 12th in the numerator, an x to the 9, and the y to the 6th in the denominator. Now, if I look at the numerators, I can't combine these two because their exponents, their bases are different. The same thing here. So then I go to look, can I reduce anything from the top and the bottom? So first I take the x's. The top x has an exponent of 15. The bottom has an exponent of 9. If you remember what I said we should do, I said we should cancel out, cross out the one with the lower exponent, which in this case is the 9, and subtract 15 minus 9. That gives me 6. So that'll leave me an x to the 6th on the top. Then I go to the y's. This is a y6 and this is a y12. I cancel out the lower one, which is a y6, and I do 12 minus 6 is 6, and it becomes 12 to y to the 6th on top. And of course, since everything canceled out in the bottom, I was left with a 1 on the bottom. Now, 1 on the bottom, I do not have to put in. So I can really write my answer as x6, y6. Remember, if the larger exponent had been on the bottom, I would have canceled out the 1 on top and left the answer on the bottom. So my base is always left where the larger exponent was. In this case, the larger exponents for both of them were on top. So my answer became on top. Again, on the bottom was a 1. My final answer is x6, y6. Jennifer, close, but the y6 is on top. It's not on the bottom. You got that?
I know how to write it like in here. How do I to answer it? That's what I'm saying.
Okay, what you could have just done is X and then do, and then right, and put a parentheses around it, and then,
Okay.
but you don't want to put a slash.
I didn't put the slash because I was trying to divide it. I was trying
Okay,
to make
I
them
get it now.
together.
But what it would look like is that it's a fraction.
Okay, I'll just put the parentheses. Thank you.
Okay, I was just wanting to make sure you knew how to do that. So that is
Professor,
question. Anybody?
how did you get X6 in the bottom?
No, I didn't get X6 in the bottom. I got X6 in the top. I don't have anything in the bottom in the end. I, this was just I just rewrote the answer.
Oh, okay, thank you.
I just rewrote the answer without the one on the bottom.
Oh, okay.
All right. So that was that question. That's working with negative exponents. We have to remember that a negative exponent means you're taking a reciprocal. So let's look at this one where it says we have 8 to the negative 1/3 power. Well, again, I see I have a negative exponent. And if you notice that after, and there's no, well, it's really not a parentheses. I could have just written this as 8 with a negative 1/3 without the parentheses. So the first thing I have to do is deal with that negative exponent. So here's my fraction line. Now this was really over 1. If something isn't a fraction, it means it really is over 1. And since its exponent is negative, that means that's going to go into the denominator. We're going to take its reciprocal. Whether the exponent is positive, whether the exponent is a whole number or fraction, the fact that it's negative means we're taking its reciprocal. Now, obviously, that means that we're left with 1 on top because there's nothing else left on the top. Now, what does the 1/3 exponent tell us? That's what we want to remember. The 1/3 exponent is equivalent to saying the cube root, the third root of 8. In other words, anytime you have a fraction as your exponent, it means that you're really doing a radical, and the number in the denominator is what we call the index of the radical. So 8 to the 1/3 is equivalent to saying the cube root of 8, which is 2, because 2 times 2 times 2 is 8. So my final answer becomes 1/2. So the answer to the second question is just 1/2. You could, and you can try them in your calculator and see that they work. Um, unless there's a question now, I'm going to continue from here talking more about exponents and actually exponential functions. Can I erase this? Anybody still need this? Okay, if there's no questions about it, then I'm going to erase it so I have a fresh board to start with. All right. What does an exponential function or an exponential equation look like? Well, here's a simple one. Let's say I say y equals 2 to the x. Remember, I could call this y, or I could call it, it's another name, we could call it f of x.
Professor, what's the name of this operation that we're doing now? Because every time I take notes, I write the name.
Yeah, it's exponential equations or functions and equations, exponential functions. Okay?
Thank you.
Okay. So I want you to see how this is different than what we've done so far. So far, I had like equations that look like this. Y equals 3x squared minus 5x plus 2. We actually learned how to solve it, not solve it, how to graph it. We also, if I called this, let's do it this. If I said g of x, instead of I called it y, and I said find g of 2, you would know that what you're doing is you're taking the 2 and replacing the x with the 2, and that would give you 3 times 2 squared minus 5 times 2 plus 2. I think everybody remembers this. This is 2 squared is 4. 4 times 3 is 12 minus 10 plus 2. That gives me a total of 4. So we would say that g of 2 is equal to 4. Now this is called a quadratic function or a polynomial function. It has exponents in it, but if you notice the difference between something like this function and this function, this is what I want to point out, is here we know what all the exponents are. What we don't know is the base. I have to tell you, when I say do g of 2, I'm telling you what number to use as the base. What number is going to, in this case, get an exponent of 2, in this case, an exponent of 1, and it's a polynomial. Over here, when I say f of x is 2 to the x, I actually know what the base is. In this case, the base is 2. What I'm changing, what my variable is the exponent. And I could ask, so this is what's called algebraic. This is an algebraic function. I'm just going to write the word algebra. This, and they saying the same thing, whether you call it y or f of x, is an exponential function. It's exponential because the variable is in the exponent. Anytime we have a variable in the exponent, we're dealing with something that's called an exponential function. Now, what kind of questions could I ask you on an exponential function? Well, I could ask you something like this. One question I might ask you is find f of 0. Okay, and I'm going to erase this because I think everybody knows this already, and I want to go on to what we're doing. What does it mean to find f of 0? It means to go to my function and wherever I have an x, put in 0. So f of 0 is going to be 2 to the 0. And we remember that 2 to the 0 is 1, because anything to the 0 exponent is 1. I could ask you to find f of -3. What does it mean to find f of -3? It means replace the x with -3. So we're doing 2 to the -3. Do you notice how we really have to know our rules of exponents here? It's not just one exponent we're having here. We could put, since my x is my variable, my exponent is my variable, I can use any number for that exponent. Now, what did we say 2 to the -3 means? Well, that means we're going to have a fraction. And since this really is like it's over 1, that means it's going to be 2 to the +3 in the denominator. We're going to take it from the numerator and put it in the denominator. And 2 to the 3rd power is 8. So this is 1/8. If I gave you, this is, as I said, a very simple, if I ask you find f to the 4th power, then that would mean do 2 to the fourth power, which means you have to do 2 times 2, 4, 8, 16. Your answer would be 16. So what in this case, when you have an exponential function, your variable, what your unknown is going to be in your exponent. Now we have to be very careful when we're doing this. The base has to be a positive number. We can't do exponential. I can do negative numbers to exponents, but I can't do an exponential function with a negative base because I never know what kind of exponent it's going to come out to be. So rule number one, my general exponential equation is going to look like this. F of x equals a to the x, where a is going to be the number we know. In this case, we used a to be 2. It could be 3. It could be 4. But it can't be -7. We cannot use, the base has to be a positive number. The exponent can be any kind of number. It could be positive. It could be negative. Because we've seen we can have positive exponents. We can have negative exponents. We can have fractions. We can have decimals. Exponents can be anything. The x can be any type of number, but the base has to be positive.
Professor, I'm so sorry. How did you get 16?
Okay, I said find f of 4, right?
Mhm.
So f of 4 would be 2 to the 4th power.
Okay.
What does 2 to the 4th power mean?
4 times 4. Okay.
2 multiplied 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16.
Okay.
And you could, again, stick this into your calculator by putting in the 2, remembering to press your exponent button. Do you know where your exponent button is?
Yes.
Okay, and then putting in 4, and you'll see you could have done each one of these on your calculator. Now, if you did this on your calculator, probably this one would come out to be a decimal, not a fraction, but you can do all of these on your calculator. So what we've mentioned is that the base has to be a positive number. What's also going to be positive is your answer, because anytime you take a positive base, and it doesn't matter whether your exponent is positive or negative or 0, the final answer is going to be a positive number. Notice, even when we did f of -3, and we took our exponent to be a negative number, since our base was positive, my final answer was 1/8. The negative exponent doesn't mean the answer is negative. It means that it's going into the denominator. It means we're taking a reciprocal. So the only number that can, there are actually 3 numbers here. There's the y, the base, and the exponent. The only one that could possibly be negative is the exponent. The base has to be positive, and the final answer has to be positive. I'm emphasizing this because when I go to the next type of topic, we're going to have to keep that in mind. What kind of questions could you be asked that have to do with exponential equations or something of that nature? So let's say I gave you a question that looks like this. This is an example of an exponential equation. Suppose I gave you 5 to the x power equals 125. This is an example of an exponential equation because my variable, my x, is in my exponent. How do I solve this kind of exponential equation? So now we're going to first do what I call the simple ones. When they get to be more complicated, I'm going to have to show you another method, but I'm going to show you the simple method for this. The base being used here on this side is 5. Try to get the number on the other side also in terms of base 5. In other words, can you write 125 as 5 to some exponent? That's what I mean by writing it in base 5. Write it as 5 to an exponent. Well, let's see. 5 times 5 gives me 25, and 25 times 5 gives me 125. Now you could just do this on your calculator. Do 5 and then times 5 until you get to this number. Count how many times you've multiplied. We multiplied the 5 3 times. So this is the same as saying 5 to the x is equal to 5 to the third power. Once you have both sides written in the same base, this is 5 to the x and this is 5 to the third, then you can ignore the base and just say, well, your x then has to be equal to 3. Now, some people could have just done that in their head, but I'm trying to give you a method. So when you have an exponential equation, what you're going to try and do is get both sides written in the same base so that you can ignore the base and just work with the exponent and set the two exponents to each other. Let's do another one. Suppose I have 2 to the 3 minus 2x exponent equaling 64. Okay, let's see what we can do with that. The base being used here is 2. So let's see if we can take this 64 and put it in base 2. Now, it's not always going to be possible to do that. That's when we're going to need that other method that I'm going to teach you. But right now, let's see if we can do it. So again, I'm doing this with my fingers or with my calculator. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. How many times did I multiply the 2? 6 times to get to the 64. So I could have written this 2 to the 3 minus 2x. That stays the same, equaling 2 to the 6th exponent. I now have them both in base 2. I now can ignore the bases and just work with the exponents. Well, the exponent on this side is 3 minus 2x. That exponent has to be equal to 6. That's what it's saying. 3 to the 9, 2 to this equals 2 to the 6. The exponent has to be equal to 6. And this becomes a relatively easy equation to solve. The first thing I'm going to do is bring the 3 to the other side. That'll give me negative 2x equals 6 minus 3, which is 3. And divide by negative 2. And my answer comes out to be negative 3 over 2. That's what my x comes out to be, because I need this to turn out to be equal to 6. Do you think you're ready to try one on your own? I'm going to give you one to try. I'm going to put it up here. And while you're trying it, I'm going to take attendance. And also I'm going to ask you if you're available, if you have any conflict with the final exam time. Okay, so here, try this example. 5 to the 8 minus 3x equals 25. See if you can figure out what x is equal to. Azia, are you okay with the date of the exam?
Yes, Professor.
Okay, you can be there, great.
Yeah.
Nashia Allen. Nashia here? We saw her before. You can send me a, if you can't, if
I am
you,
here.
Nashia, you there?
Can you hear me?
Are you okay with the final being 2 weeks from today?
Yes.
Okay, great.
Thank you.
Anna Belkis. Has anybody been in touch with Anna Belkis? Because she has not been in class the whole time. Okay. Emma. Emma, are you here today? Okay, I don't see her here. So. Messiah, are you here today? Messiah? Corey?
Here.
Are you okay with the time of the, do you have any conflict with that?
No.
You're okay, great. April,
Hey, Professor.
are you okay with the,
Yes.
okay, great. Khadija,
Yes, Professor.
okay, Khadija, are you okay with that time?
Yes, I am.
Great, thanks.
No problem.
Umar Diallo, Umar, are you here? Okay, I guess Umar is not here. Yakima,
Here.
okay, Yakima, are you okay with that timing?
I'm currently okay with it. It's just that my job, sometimes I get stuck.
Okay, so
Is-
if you see that you have a problem, please let me know as soon as you know.
Okay, thank you.
Great. In the meantime, I wrote you check that you're okay. So I'm assuming you're okay unless you let me know. Okay, Cheryl, I think you said you were okay with that, right?
Yes, Professor, I'm okay.
Great.
Yeah.
Stacia,
Yes, Professor.
you okay with that date?
Yes, Professor.
Great. Okay, Denisha is not here. Devana. Devana Jackson. I know you were here. Let me see. Did she send me a chat? Sometimes people send me chats. Okay, she did not. But I see that she's here. Okay, I'm marking her here, but I'm going to put a question mark there. Natalie. Oh, Natalie, are you here today? Natalie? Natalie, I don't see that I see that you're here, but I do not see, you're not answering me, so I'm doing a check question mark. Erica,
Good morning, Professor. I'm here.
yeah, and you're okay with that time?
What time? Oh, yeah, it doesn't bother me. I don't think so. I'll check and email you and let you know.
Okay, but I'm gonna check that you're okay. Okay, Jonathan. Jonathan, you're here today? Guess he's not here. Luke. Luke here? Here, are you okay with that date, Luke? Okay, great. Layla,
Yes, Professor, I'm here.
And you're okay with that date?
Yes.
Okay, great. Ashley,
Yeah, I'm here.
and are you okay with that date?
Yeah.
Great, thank you. Kachira,
Here.
you okay with the date?
Yeah.
Great. Great, doing. Okay, Jennifer, are you okay with that date?
Yeah, I'm here and it's fine.
And the date is fine, great. Rachel, okay, Rachel, I don't see, and Gloria, I don't see, so I have to leave that for that. Okay, so I see a couple of people did send me answers. Let's see. How we would work it. We see in this exponential equation, this side, the side that has exponent, it has a base of 5. So we want to go to the other side and see if we can put that in base 5 as well. And yes, we all know that 25 could really be written as 5 to the second power. And now, since they both have the same base, we can set their exponents equal. So we get 8 minus 3x equaling 2. And to solve this simple equation by subtracting 8 from both sides, which will give me negative 3x equals negative 6. 2 minus 8 is negative 6, and divide by negative 3. And negative 6 divided by negative 3 is positive 2. And yes, those people, I see everybody who sent me an answer did send me 2, and that is the correct answer. So that's what's called an exponential equation. Now, what can happen with an exponential equation? Well, I could give you something like this. 6 to the x equals 1 over $260. If I gave you this example, what if on one side we have a fraction? Well, I could still use this basic idea. The 216, if you think about it, if you do 6 times 6, you get 36. And 36 times 6 is 216. So this becomes 6 to the third power, 216. But that's really not a complete help, because here I have the 6's in the denominator. And here I don't have the 6 in the denominator. So what should I do? So one of the things I could do is think, well, 1 over 6 to the third, another way of writing that would be 6 to the negative 3 exponent, because when the exponent is negative, it meant that it went into the denominator. So thinking back, how did I get into the denominator? It must have been that my original exponent was negative 3. It had to be a negative because anytime I have a fraction, it must have meant that my exponent was negative. And therefore, since this would mean that the x would equal to the negative 3. We could solve it that way. Okay.
Hi, Miss Professor. Sorry, I know you took attendance.
Are you okay with the, I'm going to change, okay, I see. Date for the final.
Okay.
That's 2 days. Hello?
Okay.
You okay with that?
Yes. Perfect.
Umar, you okay with that? Umar, are you okay with May 20th, 2 weeks from today, from 10 to 12?
Yeah,
Yes, you're okay?
yeah.
Okay, great. So let me just. Okay, so Devana is okay, and Umar is okay. I'm changing you to the present. Okay. All right. So now, so this is, we could have worked it out this way. So it's possible to work it out, but it can get pretty complicated. What about something like this? What if I had something, I'm going to do a really simple one. 3 to the x equals 15. Now, 3 to the x is pretty easy. It's not, it doesn't have any complicated exponents. But you know what? This is a complicated problem. Why? Because since this is written in base 3, I would like to write the 15 in base 3. So I go to 3. 3 times 3 is 9. And 9 times 3 is 27. I never hit 15 because 15 can't be written in base 3. How can I answer this type of a question? So we know how to do the relatively easy exponential equations, but anytime there's like a little bit harder problem, either you can't put them in the same base or it's just hard to do them in the same base, we could get stuck. So we're going to be looking for another method to solve exponential equations. And in order to do that, we have to go into our next topic, which is called logarithms. I'm leaving that question open. I can't solve it yet. I'm going to be doing something that's called logarithms. And it's a strange word. I don't know where it comes from, but it's usually just abbreviated and it's called log or logs. What is a log? And actually, it sounds like it's something totally new that you've never done, but it's actually just an exponential equation written in a different format. When we have an equation that looks like this, let's say I write 2 to the 5th power equals 32. I'm just writing, which is a true statement. A base of 2 raised to the exponent 5 will give you 32. This is an exponential equation or exponential representation. We could write 32 as 2 to the 5th power. My base is 2, my exponent is 5, the answer we get is 32. Most of the time when I give you exponential equations, well, let's say I give you something like this. Say find f, suppose I gave you f of x equals 7 minus 5 to the x power. This is really an exponential equation. And I could say find f of 2. And that means I'm giving you a value for the x and replace your x with that number. In other words, this will be 7 minus 5 squared. And of course, you know how to figure that out. 5 squared is 25, so it's 7 minus 25, which is negative 18. This is A little bit more complicated exponential equation. When I have an exponential equation, my variable is going to be in the exponent. And what I'm going to ask you to be doing is figuring out the answer when I give you a number for the exponent. Now, there's another type of equation that we could be asked for. What if I gave you, and really that's what we were doing before, what if I wrote 2 to the x equals 32? In this case, over here, I gave you what the exponent should be. Over here, I'm not giving you what the exponent is going to be. I'm telling you what the final answer is going to be, and I'm asking you to figure out what the exponent is. Now, we should realize it's going to be 5. But it's a little bit backwards type of thinking. In a regular exponential function or equation, what I'm giving you is the base and the exponent and asking you what is the answer going to come out to be. If my base is 5 and my exponent is 2, then I'm just going to do 5 to the 2 and get 25. And then, of course, figure out the rest of it. That's a regular exponential equation. But when I get an equation that looks like this, where I'm asking you, I'm giving you an equation and I'm asking you to figure out, I'm not telling you what the exponent is. I'm telling you, figure out yourself what the exponent is. That's what we call it an exponential equation. And that can be a little bit more difficult because we're not going directly. Here we have to think backwards. We have to try and put this number into exponential form. We have to go backwards. And actually, that's what this log or logarithm does. Let's go back. If you didn't understand what I just said, I'm going to just give you a simple explanation of a log. So let's go back to this statement. 2 to the 5th is 32. The base, let's call it base b, to the exponent c is going to give you the number a. The b is our base. That's a number that's going to have the exponent. Remember, in exponential equations, we want this b always to be a positive number. C is our exponent. In this case, that's like the 5. The exponent is usually positive, but it could be negative. It could be a fraction. It could be a decimal, anything. The answer, which I'm going to call A, that's this 32, will also always be positive. Let's just write this. B and A in exponential equations are positive. C does not have to be positive. This is the exponential format of this expression. The log is saying the exact same thing, only a different format. In the log format, here's what we write. We write the word log. We put a subscript here. That subscript is the base, which in this case is 2. Next to the word log, we put the final answer, which is 32. And that's equal to the 5. Do you notice the same 3 numbers, the 2, the 5, and the 32, with different positions? Now notice this is a subscript. This 32 is not an exponent. It's just sitting right on, it's on the ground. The 2 is here, the 5 is an exponent, but the 2 is not the 32 is not an exponent. This is read log base 2 of 32 equals 5. If I were doing this, just bear with me for a few minutes because really all I'm doing is giving you a definition. It's a way of explaining what this log means. In other words, if I were doing it in terms of the A, B, and C, this would be written log base B of A equals C. I would venture to guess that I would say at least half of the questions that you're going to get on this topic of logs will be, you will be able to solve if you can go from the log format to the exponential format. Let's see if I can explain it better. The word log really means exponent. Here's what this is saying. The exponent that you're putting on base B to get the answer A is equal to C. C is the exponent. Why do we want to do this? Because, as I said, a lot of the questions that we were doing, these exponential equations, were asking us to find an exponent. The focus of this format is where I give you the base and I give you the exponent and I ask you what's your final answer going to be. In other words, if I give you 2 to the 5, I want you to come up with 32. Whereas if I write it in this format, log base 2 of 32, what I'm giving you again is the base, but what I'm not giving you is the exponent. I'm giving you the answer and asking you for the exponent. I'm telling you my final answer is going to be 32. What should you put base 2 to get, what exponent should you put to 2 to get to the 32? So the difference, these are what I would call inverse situations. We're focusing on different things. In the regular exponential focus, we know the base, we know the exponent. We're trying to figure out what's the final answer. Whereas in the log format, we know the base and we know the final answer, and we're trying to figure out the exponent. Again, most of the time, you're going to be, your questions, if I give you a question in exponential form, you're familiar with it. It makes sense to you, so you can figure it out. But if I give you a question in log format, it very often is difficult because it's like learning a new language. It's like I gave you a question in Greek. If you don't know Greek, you're not going to be able to answer the question. So somehow you'd like to change that question that's in Greek to a question that's in English so you can really see what's going on here. Well, that's exactly what you're going to do with logs. You're going to take your log question and translate it into exponential form so that it'll make more sense to you. So let's say I gave you a question that looks like this. Okay, let me, I'm gonna leave this on the board. B to the C equals A is the same. These are saying exactly the same thing. They mean exactly the same thing, just different formats. So let's say I gave you something that looks like this. Log base 5 of 1 over 25 equals -2. What if I give you this statement? The log base 5 of 1 over 25 is going to be equal to -2. And you think, oh, this is written in log form. What is it saying? I have to tell you, there are questions on the final where all they're asking you is convert from log format to exponential format. Well, let's see if we can do this. Remember what I told you. The number, the subscript is the base. This number must be a positive number. My base is 5. The number that's on the other side of the equal sign, that is actually the exponent. The log, the word log means exponent. The exponent that you're putting on base 5 to get this number 1 over 25 equals, it is -2. Your exponent is -2. And that equals that third number 1 over 25. And you know what? When I look at it this way, of course it makes sense. Because I know when I'm doing 5 to the -2, that negative is telling me to do the reciprocal. And the 2 is the 25. So it would be 1 over 25. It's the same exact, I didn't do any work. All I did is I converted from log format to exponential format.
Professor,
Yes.
I'm sorry. I have a question. Okay, so in the test, in whatever test we're gonna take or in the final, they're gonna give us a question where it's gonna be written out how you have it written out up there where it says log 5 1 over 25 equals -2. So to my understanding, the log where the 5 is always going to be your base, so it's always going to become, it's going to come first, which is 5. You're going to put 5. Then the one where it says equal, which is going to be -2, that's your exponent, and then the fraction is going to be your answer.
Right. Whatever number is right next to the word log,
Is the answer.
that's the one, that's your final answer.
So when we have A, B, C, and D, they're going to give us different type of problems. We just have to figure out which one is the right one.
Right.
Okay, thank you so much.
And one of the questions will be, can you interpret this? And this would be one of the answers. And then another answer might have been, they might give you something like -2 to the 5 equals 1 over 25. And of course, that would be wrong because it's the negative has to be the base, the exponent, not the base. And they could write in any one of 3 or 4 different ways. But this is the correct one because the base is the subscript and the exponent is a number on the other side. Now, let's see what else they could ask you. Now, sometimes they could ask you a question like this. What if they gave me a question that looks like this? Hey, this is, I'm gonna erase this so it doesn't get interfere. But I'm leaving this on because, again, I'm not going to give you that on the test, but this is what you have to remember. Suppose I give you an equation. This is a log equation. How do I solve this log equation? So basically, whenever you want to solve a log equation, an equation that has a log in it, you're going to want to change it from its log format to its exponential format. So how are we going to put this in exponential form? So my base is always a subscript. So that's going to be the 3. The number on the other side of the equal sign is the exponent. And that equals, what it equals is what's next to the word log, which in this case is x. Oh, now it makes sense. This is asking me to find out what 3 to the exponent of 2 is. And of course, that means that the x has to equal 9. Where it looks so confusing in the log format, when you change it from the log format to the exponential format, then you can solve it. Is that clear? Okay. I just want to go one step further before we go to review. What if you see something that looks like this? Log x equals 3. Okay, this is a different problem. I'm going to erase this. Does anybody see anything wrong with this here, this equation?
It's missing the base.
Right, it's missing what the base is. There's no base here. And I always told you there are three numbers. There's an A, B, and C. A B, a base, an A, which is the thing that's next to the word log, and a C, which is the exponent. And here, there's no base. Okay, it's not a mistake. It happens to be something that's called a common logarithm. A common logarithm means a logarithm where the base is 10. And when the base is 10, they don't put it in. In other words, if you ever see the word log and no base written in, like this one is, it really is understood that there's a 10 there. It's like when you have an X and it really means 1X. You understand the 1 is there even though nobody put in the 1. Or if you have y without no any exponent, you know that the exponent is understood to be 1. The same thing is here with log. Whenever you write the word log and you don't put in a base, you don't put in a subscript, it's understood that the subscript, the base is 10. And of course now, would this look in exponential form? How can we put this in exponential form? What's my base?
10.
10. What's my exponent? What number is my exponent?
3.
3. And that's going to be equal to my x. And of course, now I can figure out what 10 to the third is because it's 10 times 10 times 10, which is 1,000. So my x would have to be equal to 1,000.
Okay, professor. So when log x equals 3 and there's no base is always 10.
Perfect. Absolutely. Okay, so that's where we're going to stop right now. What should we be able to do at this point? We should be able to take something that's in log format and switch it to exponential format. And if it's not a hard question, we should be able to solve it. Okay. This is what where we're gonna continue from tomorrow. I really hope, I don't know if I'm going to be totally finished with logs, but if I'm not totally finished with logs by tomorrow, it will be finished with it by next Tuesday. As I said, today I want to continue our review now of chapter, okay. And chapter 5 is a chapter on fractions, or what we call rational expressions. So we're going to be doing a review of chapter 5, some of the type of problems we might see on chapter 5. Just as a reminder, the final exam is going to be on May 20th, 2 weeks from today, from 10 until 12. It will be on Blackboard. It will be set up on Blackboard just the same way the midterm was. That final is worth 35% of your final grade. I will be over the next couple of days, be looking through everybody's Blackboard and Delta Math accounts to see if you have completed all the work that's necessary for the other 65% of the class. 25% of our class work is I'm sorry, 35% of our grade is the final exams, 25% was the midterm, but the other, and 15% is homework and participation. I'm going to look at, and you have to have completed 17 of the homeworks on Delta Math to get the complete 15 points. If you did more than that, it'll be counted as extra credit. There will have been a total, there's one additional quiz that will be posted today on conics and trigonometry, so that there will have been a total of 4 quizzes on Delta Math and 2 tests, aside from the midterm and the final, on Blackboard. So that's a total of 6. You have to have done 5 of them to get complete credit for the tests and quizzes mark, which is 25% of your grade. If you've only done 4, then I'm going to take any, you got 100 on all of them. I'm going to add that, it's going to be 400 points, but I'm going to divide it by 5 because you really were supposed to take 5. Now, if you've done 6, then I'll drop the lowest mark. I also said if you do the practice final and you do well on that, I will drop your lowest mark and put the good and exchange it with the better mark from the practice final. So you can use the practice final in exchange for a bad mark if your practice final. Now, I am giving you 2 chances to do the practice final. Yes, Jennifer. Does this sound very confusing?
No. How about if we don't need to change a mark and our grades are fine, like we get hundreds?
Yes, so great.
We don't really have to do the practice final, or we do have to?
Well, truthfully, do you want to do that practice final?
Well, I'm gonna do it, but I'm saying because you're saying you're gonna use it as a mark, or and I'm
Use it as a mark if it's going to improve your average.
okay.
So if you don't do it, you're not losing anything, except you're losing because you aren't you really need to do that practice.
Yeah, I understand. I'm just trying to figure out if we were gonna get extra credit or something.
Well, the extra credit
If
is
we
that
need
if you
the
do
grade to be improved.
right, the extra credit. Look at in the end, and Jennifer, this is the end. The mark is a little bit subjective. Now, if I see somebody, and there are a few students that are that way, that have done every single homework and every single test and every single thing that I ever asked them to do, and we're here all the time, and the marks are probably average 99. Obviously, do I have to tell them that? First of all, they're going to get the best mark they possibly can. So, like there are people that are in that position, but I wouldn't tell those people, your marks and your average is great already. You don't have to do the practice midterm, or the practice final, because the practice final is really for you as practice. I'm only using it to improve your mark, but it's not, I'm not making you say it has to be a mark. But you do have to, well, I will say this, if you've only done, let's say, 3 Delta Math tests, quizzes, and 1 test on Blackboard, and then you do the practice final, and I can count that as your 5th test. But you have to have 5 test marks. I hope that's clear. Okay, with that, I'm not even going to attempt to write this because I think if I started writing, I'm not an English major, I'm a math major. If I try to write that, I'm afraid I'm going to make it even more confusing. Do the best you can. That's what if you do the best you can, I will do the best for you. That's what I'm telling you. I get pleasure from giving people good marks. I do not enjoy giving bad marks, but I am fair. I'm fair. I can't give somebody a good mark when they don't deserve it. But if somebody has made the attempts and done everything that they're supposed to have done, I, of course, will give. And if you need a little extra credit, and you've been working hard, then obviously you're going to get that extra credit. Okay, so let's look at the type of questions you could have from chapter 5, which is rational expressions. I'm going to give, so one type of question would be a division or multiplication equation. Example, suppose I gave you 25x squared minus 9 over x squared minus 16 divide by 5x plus 3 over x minus 4. Okay, I'm going to give you a couple minutes to try that as a reminder as to how to do a division. Remember, the only difference between division and multiplication and fractions is whether you take the second fraction and flip it, whether you do the reciprocal of that second fraction. Let me also mention, if as you're doing your practice final, you come across questions that you don't know how to do, you can definitely ask me how to do them and I will help you with them. And you can ask me in class also, even if it means that it's going to give somebody a better mark. I do want you, that is the point of the practice final, to see that you know how to do the examples. Rachel Seeley. Okay, I see she's on, but she's not answering. It might be her.
You talking to me, Professor?
I'm talking to, is Rachel there? I see that she's on the, yes, there certainly will be problems on the Pythagorean theorem. We'll review it later on. Okay, I just wanted to know if Rachel Seeley is okay with the final exam.
Professor, is this dividing or is that a minus sign?
I'm sorry?
Is this dividing or is this a minus
Jennifer,
sign on here?
Dividing. I'm sorry.
Hello?
Okay, let's do these together. Remember, when we're dividing, we're going to take our second fraction. We're going to leave the 25x squared minus 9 over the x squared minus 16 and take the second fraction and take it to reciprocal. Make it x minus 4 on top and 5x plus 3 on the bottom. And then instead of having a division sign, we're now going to have a multiplication sign. And what we're going to do is we're going to factor as much as we possibly can. And this we can factor into 5x plus 3 and 5x minus 3, because it's the difference of squares, 25x squared minus 9. And this can factor into x plus 4 and x minus 4, because it's also the difference of squares. So now, and these can't be factored. And what we do is we go across the top. We have a 5x on plus 3 on top. There, we can cancel it out with the 5x plus 3 on the bottom. Now, I also have a 5x minus 3, but I could not cancel out a 5x minus 3 with a 5x plus 3. I can only cancel them out if they're identical. So this cancels with this. Okay, that leaves us to be a 1 because there's nothing else left there. This, there's nothing to cancel with. The x minus 4 can cancel out with the x minus 4. So that in the end, what we're left with on top is 5x minus 3 And you could either put in a parentheses or not, it's not necessary. If there were two things, you'd have to put a parentheses, but with one thing, you can leave out the parentheses. And on the bottom, you get x plus 4. And that would be your answer for this particular example, which is exactly what Cheryl and Devana said. Okay. Let me give you another question. Any question about this? Okay, so this was a division. Again, if it would have been a multiplication, I wouldn't have taken the reciprocal of the second fraction. With a division, I reciprocate the second fraction and then I factor everything I possibly can. Okay, so let's look. At another problem. Suppose I gave you this example. Seven over x minus 6 minus 9 over x squared minus 36. This is a subtraction problem. And remember, the rules for subtraction and addition are basically the same. Okay, I'm going to give you a couple minutes to try that. And just, Ashley, anything that we learned this term is basically going to be on the final. So that includes the Pythagorean theorem. Okay, we'll do that probably next week. Ashley. Okay, let's work on this together. When we're adding or subtracting fractions, what we need to find is a common denominator. We have to have both fractions having the same denominator before we can combine the numerators. And in order to find the common denominator, what we do is we factor each denominator. Now, this is not factorable, it's as simple as we can get, but this can be broken up into x plus 6 and x minus 6. And if you recall, what I said is, when you want to find out what your common denominator is, circle all the different factors that you see. So start with your first fraction, and it only has an x minus 6. So let's circle that. If there were more, I'd circle those also. Then I go to the second fraction. And I have the first thing I see is an x plus 6. Now, I only have an x minus 6 circled. I have to circle the x plus 6. They are different things, I have to circle it. The next thing I see is an x minus 6, but I already have an x minus 6 circled. So it turned out I only had to circle two different factors, one being x minus 6 and one being x plus 6. And that is my common denominator. All the different factors written right next to each other, which are the x minus 6, I really should put this the minus, not that it makes a difference, the order. And x minus 6 is one factor and x plus 6 is another factor. So once we found the common denominator, then we want to rewrite, we want to rename the numerator. So how do I do that? I look at my original denominator. I have an x minus 6, so this was already there. What I didn't have was an x plus 6. I had an x minus 6, but I didn't have an x plus 6. I have to multiply. That means I multiply the bottom by x plus 6, which means I have to take the numerator and multiply it by x plus 6 as well. I have to do x plus 6 times 7 to make this fraction and this fraction equivalent. Because I multiplied the denominator by x plus 6, I have to multiply the numerator by x plus 6 as well. Now I compare the second fraction. There's an x plus 6 here. We already have it. We have an x minus 6 here. There's nothing new over here that we didn't have over here. We didn't multiply by anything. So therefore, since I didn't multiply the denominator by anything, I don't have to multiply the numerator by anything. Now I simplify. I multiply my final answer, I'm going to put everything over the x minus 6 and the x plus 6. When I add or subtract fractions, once I have the same denominator, I just work with the numerators. I take the x plus 6 and multiply by 7. So let's redistribute the 7. That gives me 7x plus 42. And I'm going to subtract the 9 from it. So when I do 42 minus 9, that gives me 33. So this gives me 7x plus 33 all over x minus 6 times x plus 6. So it involves quite a bit of work. You have to figure out the common denominator, rewrite each of the fractions with the same common denominator before you combine their numerators, and put it, the whole thing, don't forget to put the whole thing over the common denominator. And yes, you could have written this also, as Devana wrote it, as 7x plus 33 on top. And you could have multiplied the x minus 6 times the x plus 6. If you multiplied it out, you get x squared minus 36. I actually prefer this answer, but this is correct as well. And on a multiple choice question, they could give you either this answer or that answer. They wouldn't give you both because they're both correct answers. All right, now let's see if we have time to do one more example. I'd like to do one more example, or should we leave that for tomorrow? Okay, no comment. I'm going to try and do it. I'm going to erase this and put on the next example. This is an equation, a fractional or rational equation. 3x over x minus 3 minus 4 over x equals 12 over x squared minus 3x. How do we solve a fractional equation? So the first thing we have to do is what we did just before with adding and subtracting, of finding a common denominator. And we do that by factoring everything. This can't be factored, it's simplified. This can't be factored, it's simplified. But this could be written as x and x minus 3, common factor of x. And just like we did before, we're going to circle the different factors. So first I see an x minus 3, then I see an x. These are not the same because this includes a negative 3. And then I go over here. And the x has already been mentioned, and the x minus 3 has already been mentioned. So my common denominator becomes the x and the x minus 3. And just like we did with our previous problem, we're going to rewrite each of these fractions with the new denominator. Okay, so let's see what we have here. There's an x minus 3 over here. What I don't have is an x. The x is new over here. I've got to multiply this by x. Because I multiplied the bottom by x, I have to multiply the top by x. Well, that's not too hard. X times 3x is 3x squared. Okay. Over here, I have the x. What I don't have is an x minus 3. I'm going to have to, here's my 4, I'm going to have to multiply that by x minus 3. And over here, I have both the 12 and the x and the x minus 3. Didn't multiply anything in the denominator. I don't have to change that numerator. So I rewrote this equation with everything having the same denominator. Now, since this is an equation, before it was just an adding or subtracting, but with an equation, I can do something else. I can totally ignore the denominators now and write a new equation, which is going to be 3x squared minus 4 times x minus 3 equals 12. Once they all have the same denominator, I can just write an equation from the numerators and get a much simpler equation to work with. Okay, so now I have to solve this equation. I know I'm going a little bit over time, but let's see if we can do this. This will be 3x squared minus 4x squared minus plus 12 equals 12. And if I combine the like terms, 3x squared minus x squared is minus 4x squared is negative x squared plus 12 equals 12. And subtracting this gives me negative x squared equals 12 minus 12, which is 0, which is the same as saying dividing both sides by -1, it's giving me x squared equal to 0. And that means if x squared equal to 0, my answer should be x equals 0. But once I'm finished with it, I have to take the answer that I got, which in this case is x equal to 0, and put it into, see if it is not an extraneous root. Notice what this would give me, when x equals 0, I get 3 times 0 over 0 minus 3 minus 4 over 0. And I'm going to stop right there. I can't have a 0 in a denominator. 0 minus 3 would give me -3. That was okay. But I can't use this. This is an extraneous root, which means there's no solution to this equation. Oh, sorry, I made a major mistake on this. And nobody stopped me. I did 4 times x and got 4x squared. Erase this.
I put it up, Professor. I tell you.
Okay.
Yes,
I'm gonna
yes.
read this. This is where I'm gonna, this really should have been, I'm sorry, 3x squared minus 4x plus 12 equals 0, equals 12. Shouldn't have been 4x squared. All this was wrong. And I'm going to subtract 12 from both sides to get it because it's a quadratic equation. So that's going to give me 3x squared minus 4x equals 0, which gives me, when I have a common factor of x, this is x times 3x minus 4. So one answer is x equal to 0, which we know we can't use. We just said that before. 0 won't work. But the other answer, 3x minus 4 equals 0. That gives me 3x equals 4, and divide both sides by 3. So the answer is 4/3. I'll try and do another example like this tomorrow, because this was a hard example. Okay. So I'm going to leave you, Melissa, should I leave you? Should I leave it on?
Sure.
Melissa, should I leave you on? I'm going to leave, but I'm leaving you on Zoom.
Okay.
Thanks a lot. I'm going to stop the recording and I'm going to make you the